10.1 is right angle trigonometry, which this is something that you did last year. We're going to find the 6 trig ratios. So last year you did the 3 trig ratios, the sine, the cosine, and the tangent. We're going to do those, and then I'm going to teach you about the reciprocals. And then we're also going to determine side lengths using the trig relationships. So the SOHCAHTOA is how you can remember the sine, the cosine, and tangents, and what the ratios are. So for the sine, it is pronounced sine, okay? It's the opposite over the hypotenuse. Now you'll see this symbol a lot, okay? This is, this is theta. So theta, like when I make it, I kind of do a loop-de-loo, okay? You could also just do a 0 with a line through it, that's fine. So the O over H is opposite over hypotenuse, A over H is adjacent over hypotenuse, and then the tangent is opposite over adjacent. Remember, adjacent means next to, and then you can always find the hypotenuse because it's directly across from the right angle. So that's all stuff that you wrote down previously, or if you weren't here the quiz day, I'll post the video so that you can get all that, okay? Oh, and then you had that fun joke. What do you call a man at the beach? A tangent. So good. Okay, which is opposite over adjacent. Now remember, these are ratios. So this is the ratio of the opposite leg to the hypotenuse. So the 4 over 5, the 4/5 is the ratio. So that's why I highlighted ratio for all of these, so you understand when you're finding the sine of theta, the cosine of theta, the tangent of theta, it is a ratio, a comparison of those two sides. Okay? So you have the sine, the cosine, and the tangent. Yep. Yep.
So if you have the sine, the cosine, and the tangent with those ratios, can you make similar triangles?
If you have the sine, the cosine, and the tangent, can you make what?
Similar triangles?
Yeah, you could. They would just have to have these ratios. So like you could have one that's a 3, 4, 5, and then you could multiply by any number on the top and the bottom and make a new one. The theta is a variable, so again, it's a Greek letter. Yes. So I think last year you might have used like X or a capital A. As you progress in math, you will see that theta is the standard unknown angle symbol. Okay, so that's what we'll be using. All right, and then I asked you to do example 1, so let's check and make sure we did this correctly. So you would find the sine, the cosine, and the tangent in simplest form. So your sine is 7 over 25, your cosine of theta is 24 over 25, and your tangent of theta is 7 over 24. If you did not write in your theta symbol, it needs to be there. Okay, that is something I would take off for on a quiz. You can't have the sine, the cosine, and the tangent of nothing. It's always of an angle. Okay, so we use the theta to represent that angle. Okay, and then for B, you have to reduce all of them. So whenever you do a ratio, you want it in simplest form. So if you had 6 over 10, that's fine. Just reduce it to your 3 over 5. Cosine would be 4 over 5. And then the tangent would be 3 over 4. Those are all of the reduced values. Okay, and then once you check those, go ahead and flip it, and I'm going to give you a minute to read through the reciprocal chart that's at the very top of the next page.